Hello everyone. I'm Rahul Rupale, and today I'm discussing about my end semester exam paper. Uh, let's take a question number two. What is the data imputations, and how would you decide on the best imputation method for handling missing value in the large data set? Discuss the potential risk of using the mean value method and explain how the nearest neighbors imputations network method. Now, what is a data imputation? Data imputation refers to the process of replacing missing or incomplete value in the data sets with the sustainable value in ensure that the data set remain usable for analysis or modeling, as many algorithms cannot handle missing data effectively. Choosing the best imputation method. Firstly is the natures of data, extent of missing data, pattern of imputational analysis, available resources. Firstly is the nature of a data. Whether the data is a numerical, categorical, and time serials or text based. For second one is the extent of missing data, the percentage of missing values in the data sets. Patterns of missingness. Firstly is MCAR, missing completely at random, no relationship between the missing data and other variable. MAR, missing at random. Missingness is related to other observed variable. MNAR, missing not at random. Missingness depends on the unobserved values itself. Impact on analysis, the effect of missing data on the integrity of the result. Fifth one is available resources, computations, complexity, and time constraint. Now, risk using a mean value method. The mean value method replaces missing values with the average of observed value from the given feature. Pros: easy to implement and computation expensive. And cons: loss of variability, replacing all the missing values with the mean, reducing the nature variant and the data sets. Distorient of relationship, the imputed mean many not preserve the relationship between features, which not impact model like regressions. Not suitable for a categorical method. Mean imputation does not work for non-numerical or ordinary data. Nearest neighbor imputations can and imputations, how it is work. It is a algorithm identifies the k nearest data points based on similarities. The missing values that is imputed as a weightage average. The value of for these neighbors advantages. Contextual replacement ensure the imputed values are contextually similar of the observed data. Challenges: computation cost, KNN imputations can be slow for a large data sets because it computes distance from each missing values. What is the K nearest neighbor algorithm, and how does it work in a context of classification points based on the distance? How does choice to parameters K affect the model performance? So, what is the K nearest neighbors algorithm? The K nearest neighbor is a supervised machine learning algorithm used to for classifying and regression tasks. It is a lazy learning algorithm, meaning it does not build a explicit model during training. Instead, it makes predictions based on the similarly between data points calculate using the distance matrix. Now, how does KNN work in a classifying points? Uh, Training phase, prediction phase, and the third one is now two is a classifying training phase. KNN does not involve an explicit training phase process. Instead, it stored the entire training data set for using a prediction. Prediction phase for giving a test point, calculation distance, identify nearest neighbors, vote for class. So this is also. And how does the choice to KNN affect model performance? For the parameters k, numbers of neighbors play a critical role in the performance of KNN model: small, large, and optimal. And the advantages in a small: high sensitive to local patterns, uh, capture fine grained relationship in the data sets. Disadvantage can lead to overfit as the model become sensitive to noise outlier. Large advantages reduce the effective of a noise and smoothness predictions. Disadvantages may lead to underfitting as oversimplifying decision boundaries and many ignores importance of a local patterns. Typically, K in a choice of via cross validations balanced to K ensure that a model generalize will its neighbor to sensitive smooth. uh, Trends of K, small and large K, high variance, low bias, and large may low variance, high bias. Now we are discussing about question number 5. Explain the key difference between K-means cluster and hierarchical clusters algorithm. What are the disadvantage of hierarchical cluster over K-means when visualization cluster relationship? Firstly, clay means cluster, hierarchical cluster. Approaches is a partition-based algorithm, tree-based approach. Cluster formed fixed number of a cluster, no need of a specific number of a cluster initially. A structure non-hierarchical hierarchical algorithm, iterative optimization of centroids build a tree of a cluster. Scalability scale well with large data sets, computationally expensive of large data sets. Cluster shapes assume spherical cluster can capture complex cluster shape. Input data require numeric data can handle numerical and category data faster require for a favor resources slow due to receives marriage splitting. Now, advantage of hierarchical and over K mean clustering for visual and cluster relationship. D Danogram representation, no need for a predefined number of cluster. Third one is a cluster hierarchy, posed on a flexible cluster shape. So dendrogram hierarchical cluster provide a dendrogram which is a tree like a diagram showing the relationship between cluster. It helps visualization the entire clustering process, showing how data points are merged or split different level of uh, granularity. No need a predefined number of cluster. Unlike K-means, hierarchical cluster does not require you specific the numbers of a cluster in advance. Then dendrogram allows you to choose the desired numbers of a cluster, cutting the tree at a appropriate level. A cluster hierarchy. Hierarchical cluster reveal the hierarchy of a cluster, make it easier to understand the nearest structure and relationship between the cluster. Flexible cluster shape, since hierarchical clustering does not rely on centroid, it can identify cluster of various shapes and size. Now moving clusters. Now discussing about question number 3, explain the concept of linear regressions, how the base fit lines is determined. Write the algorithm from a linear regressions from the given input data points x and y. Linear regression is a supervised learning algorithm used to establish a linear relationship between a dependent variable triple y and how one or more independent variable triple x. Similar linear regressions model the relationship between the independent variable and the dependent variable. The line is expressed as a y is equals to mx plus cy is equals to mx plus cy is equals to mx plus c, where triple m is the slope of the line and triple c is a intercept. Multiple linear regressions extend the concept of multiple independent variables. The equal equations become y is equals to b0 plus b1 x1 plus b2 x2 that is bn. The goal of a linear regression to find the best fit line that minimize the error between the predict. Now moving forward, determine the best fit line. best fit line. Using the ordinary least equal OLS method, the OLS method minimize the sum of the square error. Uh, SSE is equals to summation of n I is equals to 1 yi dash yi is to square. The best fit line is the one of where the sum of the squared vertical distance from each data point to the line is the smallest. Now calculate the slope triple M and intercept. Slope M is equals to sigma xi minus x bar yi minus y bar upon the summation of xi minus x bar square. Interception is c is equals to y bar minus x m x bar. Gradient distant alternative model start with initial guesses from a triple M and CCC when iterative updates to them to minimize the error using the gradient of the cost function. Now algorithm for linear regression inputted data point x is equals to 1, 2, 3, 4, and y is equals to y1, y2. That is output slope triple M, intercept triple C, and equations of the best fit lines. Calculate the means, compute the mean and x and y. X bar is equals to sigma summation of xi upon my n. Y bar is equals to summation of yi upon my n. Calculate the slope. M is equals to summation of xi minus x y minus y divided by summation of xi minus x का whole square. Calculate करेंगे c is equals to y bar minus mx bar. Now use triple M and CCC regressions best fit line equations. Y is equals to mx plus cy is equals to mx plus cy is equals to mx plus c. Predict the new value from given x is used to equation. If y is equals to mx plus cy is equals to mx plus cy, uh, mx plus c is equals to estimate of y. Now we're discussing our last questions. What are the advantage and disadvantage of using a decision tree of a classification task? How to assemble method like random forest and boosting improve the performance of a decision tree. Advantages and decision tree for classification task. Firstly, easy and interpreted and visualization. No need for features scaling. Third is a handle non-linear relationship feature importance. Decision tree can be easily visualized, making them highly interpreted. This is especially useful for explaining predictions to non-technical stakeholder. No need for feature scaling. Decision trees work well without required normalization and distribution of data, and they based on features values directly. Handle non-linear relationship. They can model non-linear relationship effectively as the tree structure divided into feature scam into arbitrary steps. Fourth one is the feature importance. Decision tree provide insight into features importance, highlighting which variables contribute most of the decision makes process. Now disadvantages of decision tree. First one is outfitting, and second outfitting. Decision tree can easily outfit the training data, especially if the trees is deep and complex. High variance, small changes in the data can result in a significantly different tree structure, making the model uh, unstable. Bias toward dominant features with more level of or a large range may dominant split potentially lead of the bias model. Limited generalization without running or ensemble method, decision tree may struggle to generalize well unseen uh, data. Now, moving forward and how assemble methods improve decision tree. Firstly, assemble method like a random forest and a boosting combine multiple decision trees to improve their performance by addressing and the limitations of a single tree. Firstly, random forest, how it is work, build a multiple decision tree on the different subset of the data and use a random sum feature selected at each split to introduce diversity outputs the final predictions as the majority votes. Now moving advantages of single trees, reduce overfitting combinations, prediction for a multiple tree, reduce the variance of the models, improve generalization, better performance on unseen data, used to averaging, handles high dimensionally random features, selecting ensure diversity and mitigate bias towards dominant feature. Now, second, boosting. How it is work? Sequentially build a decision tree where each tree is correct the error of the previous ones. Focus more on misclassified data points by assigning higher weights on them. Combine the predictions of all tree using the weight voting and averaging. Advantages of single tree: improve accuracy, handling bias and variance, adaptive. Now moving up, improve accuracy. Each tree is focused on the reducing the radical error resulting in the store over model. But effectively reduce both bias and variance, improving generation. Adaptive boosting adapts the complexity of the data, allowing it to handle difficult data set well. Now, thank you for watching. This and this is all about my